Hey guys, this lesson will start for 1, and depending on how much time, there may be a second video. 4.1 is on angles and their measures. So first off, remember we have degrees, we have radians, and we have different ways to measure angles. One of the main things to remember is that a degree doesn't have any relationship with a linear unit, meaning a degree doesn't relate to inches, feet, centimeters, things of that nature. So another way to look at degrees is in what we call DMS, which is degrees, minutes, and seconds. And it's just another way to measure an angle. Each degree is 60 minutes. Each minute, if you could guess, is 60 seconds. So it's almost like a degree is an hour, if you kind of want to think about like clock arithmetic. Which means, if we wanted to convert between degrees and seconds, that each degree is 3,600 seconds, because 60 times 60 is 3,600. So let's do some examples, and at any time you can pause the video and try out some of these problems and then unpause to see if you get it right. So the first one, 37.425 degrees, and we're going to convert this to DMS. So we have degrees. That would be this part. This is our degree. We need to convert this to our minutes and our seconds. The way we do that is just like any other conversion. We're going to multiply by whatever I need. If I have 0.425 degrees, to get it into minutes, I'm going to multiply by 60 minutes over 1 degree. This way, remember, our degree label would cancel out. And this gives us 25.5 minutes. Now I have this little decimal left. So if I multiply it by 60 seconds, or in 1 minute, again, labels cancel, I get 30 seconds. So 37.425 is 37 degrees, 25 minutes, and 30 seconds. These are the symbols for minutes and seconds, or the tick marks. All right, now you try number 2. 45.375 degrees. 45.375 degrees. This should give you 45 degrees, 22 minutes, 30 seconds. Now, of course, there are always ways to use the calculator to kind of help us. If you look at your calculator and you notice right here at the apps button, written in blue, is the word angle. So we can use the second apps to bring up our angle menu. And you see there's an angle symbol, a minute symbol, then there's an R. Then this, in number 4, has an arrow to DMS. So what that means is it's going to convert anything you type into DMS. So for example, if I wanted to convert 21.289 degrees to DMS, I would type it and then use option 4 under my angle menu. Enter twice, and there you go. 21 degrees, 17 minutes, and 20.4 seconds. There's nothing past seconds that we use, so you don't have to convert that 0.4. Again, that is in the second apps, which is the angle menu. Just like you need to be able to convert from degrees to degree minute seconds, you should be able to go from degree minute seconds back to just the basic degrees. So let's do that next. So number 3, Let's do 42 degrees, 24 minutes, 36 seconds. We have our degrees, so we know this is going to be 42 point something. We're going to convert this first, so 24 minutes. And again, remember, I want it to become degrees, so this time I'm going to multiply by 1 degree over 60 minutes. That's 24 over 60, or 0.4 as a decimal. Then I'm going to convert the 36 seconds. So 36 seconds in 1 degree. Remember, there are 3,600 seconds, or I could convert the seconds to minutes and then the minutes to degrees. And that would be multiplying by 1 over 60 twice, which would give me the 1 over 360, or 1 over 3,600, excuse me. This gives me 36 over 3,600, which is 0.01. We combine these two to be 0.41, so this is 42.41 degrees. Now you try number 4. 58 degrees, 14 minutes, and 18 seconds. This should give you 58.2383 with this last 3 repeating. When you convert the 14 minutes, you get 0.23 repeating. When you convert the 18 seconds, you get 0.005. So because of that, when you add the 0.005 to 2.3 repeating, that is where the 2.2383 repeating comes from. Now be mindful, you will have 2-part quizzes and tests, so you should be able to do this without a calculator. But I'm going to show you how to do it with a calculator, just in case you have some crazy ones. So just like there is the DMS converter, in the angle menu, there's also the degrees and the minutes button. The seconds button is not located in the angles menu. It is actually located just on the regular calculator. So let's do another problem. What if we do 20 second angle degrees, 6 second angle seconds, and then 18 minutes, and then 18 seconds. If you look down here at your plus button, in green is your seconds. Because it's green, you have to hit alpha. So alpha plus would give me my double tick marks. When I hit enter, there's your decimal conversion of 20.105. So the angle degree and the minutes tick mark are in your angle menu, so second apps. But the minutes would be alpha plus. Be able to go back and forth between both of these. Okay, the next thing in this unit is all about radians. And if you remember from Math 3, a radian comes from, if we have a central angle in a circle, and forgive my crazy looking circle, if I have a radius of some length, the arc length, which is kind of like the crust of a pizza, remember arc length is a part of the circumference. If my radius and my arc length are the same, then this angle measure is 1 radian. And remember, angle measures and arc lengths are 2 different things. Arc measurement will equal the central angle, but that is not the arc length. Arc length is based off circumference. So one of the things you learned back in Math 3 was how to convert. And remember, if we're going from radians to degrees, then we're going to multiply by 180 over pi, because it's 180 degrees are in pi radians. If you remember, a full circle is 360 or 2 pi, so that is why 180 degrees is 1 pi. If you're going the opposite way, degrees to radians, then you're going to multiply by the reciprocal, which is pi radians over 180 degrees. Now take a second and make sure you're good with converting. Do 90 degrees to radians and pi over 10 radians to degrees. Okay. 90 degrees is pi over 2 radians. Please do not say 1/2 pi. We always like to write pi in the numerator. And then pi over 10 radians is 18 degrees. There will be lots of practice converting whenever we do some unit circle problems later and other types of problems where sometimes it's easier to see or to remember things when they're in degree form. The last thing that is in this section is arc length. And hopefully you remember the arc length formulas from Math 3. But just in case, when we are in degree mode, the formula is S equals pi r theta over 180. S is my arc length. Pi is just pi. R is the length of my radius. Theta is the Greek letter that we let represent angle. And then 180 is 180. Now, if I were to have a problem in radians, originally in radians, I have a much shorter formula. Think about when we convert from degrees to radians. We multiply by 180 over pi or pi over 180. Which one? We want to convert to radians, we multiply. And this pi and 180 cancel out. So this is S equals r theta. What this brings about is if you're ever confused about which formula to use, say you're just giving the S and the R, radians is the easiest angle to solve for. Then you can always convert it to degrees later. So let's do a couple problems. So the first one, if the radius is 2 and theta is 25 radian, what does that mean the arc length would be? Just 50, and if it's 2, let's put a label on this feet, then it would be 50 feet, because 2 times 25 is 50. Remember, the theta, the radian, will not have an effect on the linear measurement of feet. Same thing happens whenever it is in degrees. You just plug it in the degree formula and simplify it as much as possible. Some of the more complicated problems that you'll see are concentric circles, which just means a circle within a circle. Hopefully you heard that in Math 3. So for example, if we have R1 is 11 centimeters, R2 is 44 centimeters, and S1 is 9 centimeters. Because it's a circle inside a circle, then that means the angles will be the same, the central angle. So I can solve for that first. S equals r theta. S is 9, R is 11. I don't know theta. So what that tells me is theta is 9/11ths, radians. Remember, if you want to convert it, you can, but it's nice and short and sweet, just in radians. Then my R2, my bigger circle, has a radius of 44. So S would equal 44 times 9 over 11, which is 36 centimeters. And hopefully you notice the relationship between the arc lengths and the radius. Times 4 times 4, they are proportional to each other. And that's something that hopefully you discovered back in Math 3. The last thing could be if you're asked to find the perimeter of a sector. Remember, perimeter of a sector would be the radius plus the arc length. So perimeter would be R plus S. Okay? And that is all of 4.1.